I'll now do question 2 on exam 2. In the figure above, the mass of the block is 8.5 kilograms, and the angle theta is 30 degrees. Find, in part A, the tension in the cord, part B, the normal force acting on the block, and in part C, if the cord is cut, find the magnitude of the resultant acceleration of the block. Okay, so first I'll draw a free body diagram as I start part A. So I have my x direction is going up the incline, and a tension force is acting in the positive x direction, and since mg is acting vertically down, I can break mg up into a y component and an x component. Here theta is shown here, so this is theta here. So let me just put the components on here. We've done this enough that we can just write these down now. We've done problems like this so many times. So we have the y component of the weight is mg cosine theta acting vertically down. And in the opposite direction is the normal force. And then opposite the tension force is the x component of the weight, mg sine theta, acting in a negative x direction. So now, to do part A, I just want to find the tension in the cord. And if I sum the forces in the x direction, I see that plus t minus mg sine theta is equal to 0. So the tension is equal to mg sine theta, which is equal to the mass, 8.5 kilograms, times 9.8 meters per second squared, times the sine of 30 degrees. And then when I put in the numbers in the calculator, I get the tension is 42 newtons. In part B, we now apply Newton's second law in the y direction to find the normal force. The sum of the forces in the y direction is equal to plus n minus mg cosine theta and that's equal to 0. So n must be equal to mg cosine theta, which is equal to 8.5 kilograms times 9.8 meters per second squared times the cosine of 30 degrees. And that results in a normal force of 72 newtons. Part C, if we cut the cord, then the tension force goes to 0. And so if we then apply Newton's second law to the body in the x direction, the sum of the forces in the x direction is just equal to minus mg sine theta. And now, since this is a net force, this is equal to m times a. And the masses cancel out. And a is equal to minus g sine theta, which is equal to minus 9.8 meters per second squared times 0.5. And that tells us that the acceleration is minus 4.9 meters per second squared. And I gave you full credit if you just got the magnitude right in this problem. In fact, that's what the problem asks for. Excuse me, it shouldn't be minus not 4.9. The magnitude of A is 4.9 meters per second squared. And that's the solution to the second problem in exam 2.